Hi, my name is In-Hwan. In this video, I'm presenting the unsupervised method to estimate pedestrian groups for better forecasting future trajectories. The goal of predicting human trajectories is to infer socially acceptable paths based on previous steps. This is an essential subtask for many applications, such as self-driving cars, delivery bots, urban development plans, robot navigation systems, and surveillance systems. However, predicting the future paths in real life is still a complex problem. One of the most significant issues is that people don't just go straight. People choose behavior patterns through their inherent decision at every moment, but it is difficult for the model to know that. So, the network should predict the person's choice only with their past movements. In this example, the most visible patterns are group working, joining, and avoidance. There is a lot of group behavior here. Computational social scientists analyze that up to 70% of people form groups. Here is how existing models have solved the human trajectory prediction. The models observe one person's history coordinate sequence and then predict the future trajectory. Then, what about two people? The model takes each past trajectory, aggregate the interaction, and predict their future trajectory respectively. However, we can expect that both are within a group and will work at the same speed and direction. This is our motivation, and we have made this intuition predictable by the network. We have designed our model to estimate groups for all people in the scene in an unsupervised manner and use this information for trajectory prediction. These are the demo video of our group estimation results. Various methodologies were tried to capture group behavior, and early methods hope to share group information through interaction aggregation between individuals. Alternatively, there were some attempts to use the additional group information. However, since these methods use additional inputs, it cannot be fairly compared to existing methods. To go further, we presented an architecture that simultaneously estimates this group information and trajectory prediction called GP graph. Our GP graph architecture is as follows. Our network predicts trajectories by literally pulling the pedestrians into groups and integrating pedestrian group hierarchies output. Here, our approach can take three advantages. We can reduce the complexity of trajectory prediction, alleviate inherent scene bias, and offers a graph augmentation effect with pedestrian node grouping. First, we define the novel operators for pedestrian grouping. Using the feature distance between pedestrians, we extract the colleague candidates. Then, we arrange the colleague members in associated groups. Next, we define a group-based pedestrian feature pulling and unpulling operators. Lastly, we construct the pedestrian group hierarchy graph using the aforementioned operators. Through this group hierarchy graph, our model can capture agent-wise and intra- and intergroup interactions. Despite many advantages of group pooling, there is a crucial issue that backpropagation cannot be done because it is a non-differentiable function. We solve this problem by proposing a straight-through group estimator that connects the gradient flow in an alternative way. We additionally use the estimated group index for trajectory sampling part. Unlike conventional scene level and pedestrian level sampling, we propose a group level method of sharing a latent vector between the same group members while independent of other groups. This is the visualization of our group estimation and trajectory prediction results. Our GP graph estimates the group well, even though it is trained in an unsupervised method, and also predict the accurate future paths of groups. This is our trajectory prediction results. Our GP graph shows consistent performance improvements on all the baseline models. The result shows that the models can benefit from the group awareness queue. And our pedestrian group pulling and unpulling method shows promising results on all the distance, collision, and temporal correlation metrics. Thank you for your interest in our work. Our quotes are available online.